This is my end of quarter video for winter 2020. My research is on promoting social benefits in volunteer-based tasking systems. Examples of tasking systems are Uber, Postmates, and TaskRabbit, where users help each other in the physical real world. Volunteer-based systems are different from other tasking systems in that helpers aren't paid. Volunteers help each other because they care about their community and because they in turn are helped by other volunteers in the future. Let me briefly introduce you to the problem space that motivates my research. By helping each other through small tasks, community members have a way to connect and help the community. Volunteers often have social motivations to participate in systems, or they might learn new social goals as they participate. Some volunteers might want to sustain or strengthen their existing social network. Others might want to have a diversity of interactions with people they might not have met. They might not otherwise meet through their existing routines. Social goals extend to relationships between pairs of users too. Some users might want to reconnect with users for some reason, and others might prefer not to reconnect for a different reason. Looking at other existing work in both research and industry, there's a lot of work on how volunteer-based tasking systems, can meet several goals. Within system goals, there has been research, for example, on how to prioritize some tasks as more important than others. There's also been research on user experience goals, such as how to cause volunteers minimal deviation from their existing routine that prior work has explored. But no prior work has explored social goals that users have in such volunteer-based tasking systems. These social goals are important because it is how people actually interact in the real world while helping their communities and through other interactions. It is important that we build technology that supports human behavior the way it actually is, not how we expect it to be. And I see incorporating social goals as a way of humanizing tasking systems. They're also important because as we increase the social benefit that volunteers derive from these systems, we can imagine volunteers being more committed to helping their community, more satisfied from their interactions, and more engaged in using the systems to complete future tasks. It might still be unclear why we're thinking about social benefit in tasking systems, which seem pretty transactional, so I wanted to draw an analogy from urban planning to help explain. In the 1960s, most planners focused on increasing efficiency within neighborhoods, building wide roads to reduce traffic. In doing so, they built narrow sidewalks to increase space for the roads. A writer called Jane Jacobs conducted a few case studies of how people actually interact within neighborhoods and found something interesting. She found that having wide sidewalks rather than narrow sidewalks had an intricate positive impact on the community. Among other benefits, she said wide sidewalks led to more interactions among community members, a collective enforcement of safety in the neighborhood, and more engagement in public organizations. She went further to explain the power of multiple of these small interactions. She said, most of it is ostensibly utterly trivial, but the sum is not trivial at all. The sum of such casual public contact at a local level is a feeling for the public identity of people, a web of public respect and trust. In the same way, I don't think a small interaction of helping another person will impact their social lives at all. But I think multiple of these interactions together, if facilitated correctly, can have major social impact. The analogy from urban planning is important because, just like our physical infrastructure impacts our social interactions, so does our digital infrastructure. Bringing the analogy closer to home, the question I'm interested in is, what does widening sidewalks look like for my research? To answer that question, let me explain my conceptual approach. There's three aspects that I think are important to build systems that promote social benefit. The first is to model social goals. The second is to promote repeated interactions. And the third is to balance trade-offs with other goals. And I'll walk through each one of these one at a time. In modeling social goals, it's important to realize that different users have different social goals. Some might want to increase the diversity of their interactions, while others might want to strengthen their existing social networks. Unfortunately, these goals are in conflict with each other. If we build a system that promotes either of these goals, we would be negatively impacting users with the other goals. To solve this problem, we calculate social goals differently for each user using what they self-identify through the design's interface. By using self-identification instead of prediction, the system gets the volunteer's truest answer and gives them the control of making a decision. An added benefit of such a technique is that we make users more conscious of their social goals. This brings us to the second aspect that I think is important in my conceptual approach of promoting repeated interactions. This goal is This aspect is most important for users who wish to increase diversity of interactions um, through their interactions with the system. For such users, we face a difficult question. After how many interactions between a pair of strangers is there social benefit? To simplify the question, we could think, how many interactions does it take for a pair of strangers to smile when they next see each other in passing, as we do to our neighbors? The question is important because, in the case that we increase diversity of interaction a lot, such as by striving for only one interaction per pair, it could lead to less familiarity between the users. This is because the interactions users have in tasking systems are small and transactional. Often, all they will involve is greetings and a thank you. So we can imagine we need more interactions to have any social benefit. To solve this, we might err on the side of having more repeated interactions between a pair of users. However, this would negatively impact diversity of interactions. Overall, we see that these two goals are in conflict with each other. However, even if we can somehow compute the optimal number of repeated interactions for users in general, it would neglect the fact that social relationships between any two users is unique, and our solution should address this uniqueness. To resolve this conflict, our design collects feedback from users after each interaction. We ask the user about whether they would like to interact with the other user again and for a score of their relationship. Then the system doesn't match users who don't want to interact and deprioritizes matching users whose relationship scores have plateaued. By asking feedback from users, we can approximate the optimal number of repeated interactions for any two users. More importantly, it allows for an approach that is flexible based on the unique relationship of any two users, since we compute optimal values for each pair of users separately. This brings us to the last aspect, which I think is important in my conceptual approach, of balancing trade-offs with other goals in the system. So out of all these other goals, let's focus on the user experience goal that helpers should have minimal deviation from their existing routine while completing a task. There isn't a way to pre-compute which task to assign to which user beforehand because user routes are uncertain. So we only notify a helper when they are near the task area, let's say 100 meters from it. However, this approach doesn't scale when thinking about social goals, because if we assign the first task the volunteer comes across, we might miss the opportunity of matching them with a future task that has greater social benefit. We might think to instead wait for a more ideal task with greater social benefit, only to find that the helper doesn't reach any such task, and we missed an opportunity of assigning the task before. It seems like there is another conflict between these other goals in tasking systems and the social goals that we'd like to promote, and we need a way to balance the trade-offs between them. To resolve this conflict, our system uses the hit-or-wait framework, which is a product of past research in my lab. I think the best way to explain how it works is through a demo that I'll show in my next slide, but let me briefly explain it. Hit-or-wait decides on the fly whether to hit, that is, assign the current task, or wait for future tasks. It computes the value of waiting by looking at all possible future routes of the helper and tasks along these routes to make an educated decision. It meets our need for minimal deviation because it only assigns a task when the user is near it. And it also meets the need of prioritizing social goals because it can meaningfully compute the value of waiting and make educated decisions. Let me now walk you through an example of how my system would work. Imagine we have some sample data we've collected. We have the users in our system, their past routes, the active tasks in the system, and a sense of user relationships. For this example, we have 4 users: Alice, Bob, Cooper, and Morty. For each user, we also have their social goal, which is either to increase diversity or to strengthen their existing social network. We have past routes for each user, with each location representing the latitude, longitude, and time when the location data was collected. We also know the active tasks in our system, the location of each of these tasks, and the user who requested these tasks. And we know the relationships between users in the system. If you look at the first key value pair, you'll see that users 4 and 1, that is Morty and Alice, have a friendship score of 0, which means they don't know each other. The last key value pair shows that users 4 and 3, that is Morty and Cooper, have a friendship score of 1, which means they are best friends. Let's now see how the system would make decisions of which task to assign along Morty's route. Remember that Morty's social goal is to sustain and strengthen his existing social network, and that Morty and Cooper are best friends. When Morty is at this first location, we recognize that he is near Alice's task. The system decides to wait because the current task doesn't align with Morty's social goal, and the system predicts that Morty is likely to come across a task in the future with more social benefit. As a reminder, Alice and Morty are not friends, and Morty's social goal is to strengthen his existing social network, which doesn't align with this task. At the second location, the system also waits for the exact same reasons. At the third location, the system still waits because there is no task nearby. At the fourth location, the system finally hits because Morty is near Cooper's task. Since he is best friends with Cooper, this task aligns with his social goal of strengthening his existing network. It is important to realize that the system would have made very different decisions if Morty had a different social goal. Through many such decisions, the system is able to assign tasks to volunteers that align with their social goals and promote social benefit in the system at large. For future directions, there's 2 tasks that I'm going to be focusing on. The first is that I need to run preliminary tests to identify whether asking users to self-identify their social goals and collecting feedback could cause disruption. If this seems to be a problem, we might need to rethink our approach. The second direction is to design and run a study to see if users perceived any social benefit or felt increased commitment or satisfaction by using the system. I'm also interested to see if there is any impact on helping behavior of volunteers through the system. Thank you for listening, and please write back to me if you have any feedback on my presentation.